The question says that a body of mass 0.40 kilogram moving initially with constant speed of 10 meter per second to the north is subjected to a constant force of 8 Newton directed towards the south for 30 seconds. Take the instant of force applied to be t equals to 0, the position of body at that time to be x equals to 0, and predict its position at t equals to minus 5 second, 25 second and 100 second. So this question is about one-dimensional motion. Let us assume that the upward direction is north in this case. Now let us assume that at t equals to 0 the body is here, progressing forward with an initial velocity of 10 meter per constant speed of 10 meter per second. So initially it is traveling at 10 meter per second. Now at this instant t equals to 0, force of magnitude 8 Newton is directed towards south, that is in negative direction, or the direction opposite to that of the motion of the body. So we have to find at first the position at t equals to minus 5 seconds. Minus 5 here is referred to the 5 seconds before time t equals to 0. So since the force is applied at t equals to 0, so we can assume that time before t equals to 0 the body would be traveling with a constant speed of 10 meter per second. So its position, since it is one-dimensional motion, so its position would be somewhere here, and its position can be found out by displacement equals to velocity multiplied by time interval. Time interval is 5 second multiplied by velocity, that is 10 meter per second. Now it would be 50 meters. So it would be 50 meters behind the initial behind the point at which t equals to 0 it is. Now for t equals to 25 seconds, we know that the force is applied at after t equals to 0 and it is applied till 30 seconds. So at 25 seconds the force would be applied on this body. So let us find out what is the acceleration. Given force equals to mass times acceleration. Now force is 8 Newton and mass is 0.4 kilogram. So acceleration would be equals to 20 meter per second square. And this force is acting southward, so we can take acceleration in the opposite direction of motion, and since it is in one dimension, so we can represent it by sign of negative in this. So acceleration we have calculated, acceleration is applied with the magnitude of 20 meter per second square from time t equals to 0 to time t equals to 30 second. Now finding the position at t equals to 25 second, we can apply this equation of motion, that is s equals to ut plus half at square. Now we see that u equals to 10 meter per second, which is initial speed, and time interval is 25 seconds. Since the acceleration is constant, so we can apply this equation, half 20 times t square, that is 25 square. Now this would be equal to, so we can do minus here, so this will turn out to be minus. So 250 minus 625 0, or it would be minus 6000 meter. So at time t equals to 25, seconds, the position would be minus 6 kilometer in the backward direction, or minus 6 kilometers. Now let us find out for t equals to 100 second. We have the data here, so we can erase it a little bit. We see that the constant acceleration is applied till 30 seconds only. So let us approach this equation with a graph. Initially, let it be VT graph. So initially the velocity is 10 meter per second, or speed in one direction is 10 meter per second, and deaccelerating force of with an acceleration of minus 20 meter per second is applied till 30 seconds, and we have to calculate the displacement at 100 second. This is 10 meter per second. So we can represent constant deacceleration with negative slope of straight line. Mind it that this graph is not to the scale. And after that, with some constant velocity, after application of the force, since the force is application of force is removed after 30 seconds, so it can go with the constant velocity. Now we can say that the area of VT graph will give the displacement. So the area of this triangle plus this trapezium will give us the displacement in this entire duration. So the area of this triangle would be positive and this would be negative, as this is deaccelerating force, so the body is moving in the negative direction of x-axis. So let us calculate the area of this small triangle first. Let it be represented by O, A, B, this point be C, this point be D, and E, F. So the total displacement would be area of triangle ABC, triangle ABO, plus area of CDFE. So the triangle, so this area would be equal to half times 10 times, we don't know the base or the time at which V comes to 0. So let us calculate this. So V equals to U plus AT. V would be equal to 0, plus initial velocity is 10, plus acceleration is minus of 20 multiplied by time, t equals to 0.5 second. So t would be 0.5 second in meters. So 2.5 meter positive. Now finding the area of this trapezium, we will have half multiplied by summation of these two horizontal lines. So this line would be 100 minus 0.5, so it would be 99.5, plus this line would be CD would be 70 multiplied by this height. Now this height is nothing but the velocity at t equals to 30 seconds. So we can find out with the equation of velocity V equals to U plus AT, U equals to 10 plus minus of 20, that is acceleration times 30 seconds. So this velocity would be equal to minus 590 meter per second. So multiplied by 590. This again would be in meter, and this entire area is in negative side of the axis. So this the area would be negative. Let us calculate this. So it would be 550,000 2.5 meter negative. Now adding these two areas, we will get the position at t equals to 100 seconds. So after summation at t equals to 100, we will get minus 50 kilometers. So the particle is at minus 50 kilometer at t equals to 100 seconds. Thank you.